problem together where we have four 1,5 volt cells connected in series, giving us a total voltage here of 6 volts. We're going to also make the resistance of the conducting wires and the cells negligible. In this circuit, we then have a 3 ohm resistor connected in series. Then we see the series circuit splits, 2 parallel branches. We also see that the 2 parallel branches have a resistance of 6 ohm and 4 ohm in it. They combine, and then there's another 7 ohm resistor. I've also just included a switch here, and as you can see, the switch is closed, so we know that current is flowing. For our first question, calculate the total parallel resistance. I'm going to use this formula, 1 over Rp equals 1 over 6 ohms plus 1 over 4 ohms. And if you go and simplify this, it's going to give you, let's give a 12 under the line, 6 times 2, 4 times 3, basic math here, giving you 5 over 12. But remember, that's 1 over Rp. So if we just go and calculate Rp, it's going to be 12 over 5, which should give you 2,4 ohm. And that is our total parallel resistance. The next question, calculate the total resistance. Here we're going to say total resistance equals the resistors in series plus the resistors in parallel. The resistors in series will be 3 ohm plus 7 ohm plus this 2,4 ohm, which is our total for the parallel circuit. This gives me a total of 12,4 ohm. Then if we go and look at our total current, for the series circuit and the parallel circuit here, because they didn't give us names for the resistors, just write down the formula as it has been given on your formula sheet and substitute your values. No specific subscript here given for the resistors. To go and calculate the total current, we can now use Ohm's law, which says that I total is going to be equal to V total divided by R total. We know that our total voltage here is 6 volts and our total resistance will be 12,4. So if we go and calculate 6 divided by 12.4, it gives you 0,48 ampere, rounded off to 2 decimal values. That's our total current in our circuit. Then to go and calculate the current going through our 6 ohm and our 4 ohm resistor, the easiest way for me to do it is to say that the voltage in the parallel circuit is equal to the total current because the total current goes through the parallel circuit. Now I know it splits into branches, but it comes together and it's eventually the same total amount. So the voltage here over my parallel circuit is going to be equal to my total current times the resistance in my parallel circuit. So to go and calculate the voltage in my parallel circuit, I take my 0,48 ampere and I go and I multiply that with my total parallel resistance of 2,4 ohm. This will give you a value of 1,152 volts. You can round that off to 2 decimals, 1,15 volts. So now I know if I were to go and connect a voltmeter over the 6 ohm resistor, it will have a value of 1,15 volts, or over the 4 ohm resistor, it will also have a value of 1,15 volts. So to go and calculate the current in my 6 ohm resistor, I'm going to say the voltage in the parallel circuit divided by the resistance. And here we know the voltage we've just calculated as 1,15 volts, and we divide that by the 6. So 1,15 divided by 6 gives you 0,19 ampere. We know that the current going through the 4 ohm resistor will then be 0,48 ampere minus the 0,19, but let's just do the same calculation here. We say voltage parallel divided by resistance. It's going to give you 1,15 divided by 4. That gives you 0,29 ampere. So if you go and you add 0,29 and 0,19, we know that this gives us our total current of 0,48 ampere. Another way in which you could have done this is since you know the total current is 0.48 ampere, you can go and calculate the volts used here by the 3 ohm resistor in series. We can say the volts is going to be equal to I times R, where I is now the total current of 0.48, which we multiply with the resistance of 3. And this gives you voltage of 1.44 volts. Then we go to our 7 ohm resistor, we connect the voltmeter, and we go and calculate the voltage used by the 7 ohm resistor. It's also going to be I times R, where the current is still 0.48. We multiply it with the 7 ohm resistor, and 0.48 times 7 gives you 3.36 volts. So if we have 6 volts and 1.44 volts is used by our 3 ohm resistor and 3.36 volts is used by our 7 ohm resistor, we are left with 1.2 volts for our parallel circuit. And as you can see, that's just basically what we got through this other calculation as well. We got 1.15. So if you use the first method and you got 1.15, or if you use the second method and got 1.2, both those values will be correct and will be marked as such. So as you can see here, there is more than one way to answer these questions. Very important also that you notice that the current going through the 6 ohm resistor is less than the current going through the 4 ohm resistor. And the reason for that is that current will want to go through the pathway of least resistance.